So today we are going to be talking about building NFTs, and yes, as I think this is our second last session of the Ethereum deep dive. So it's going to be full of understanding and full of knowledge. We are going to build using hardhat. So today we are not going to use the online IDE, which is Remix IDE for building our smart contracts. We are also going to see how we can put things together. Okay, let's get started. So we are going to have mainly 2 lectures. I hope time will take us through. So we are going to start with building a basic NFT contract on Ethereum. This tutorial is mainly to help us with knowing how to put together different components on our local developer environment to build both a front end, a back end, and the smart contract. Let's build your basic NFT on Ethereum. So building your own basic NFT contract on Ethereum. This is a step-by-step tutorial going over how to build your own simple NFT contract on the Ethereum network using hardhat and OpenZeppelin contracts. We'll write the Solidity contract code and deploy it to a test network using hardhat scripts. Okay. Make sure you have MetaMask installed and set up. Download and install Node.js on your computer. Use the LTS version. Okay, so make sure you have these as prerequisite: MetaMask, you have Node.js, I have dash version. So for my computer, I mainly switch from 16 to 18, but you need to have Node installed. Request some Supolia. So today, since I'm going to be using many things, environmental variables, I'm going to use another search engine to power up this DApp. Okay, setting up hardhat. To build the smart contract, we'll use hardhat this time. Hardhat is an Ethereum development environment and framework that allows for stack Ethereum development on your local computer. Without relying on browser IDEs such as Remix. It also allows for easier debugging, faster iterations, and writing scripts and tests to go along with your contract code. To set up a hardhat project, first create a new folder. Your computer we will name as NFT. So let's have a new folder. I usually create mine and okay, so I have Ethereum deep dive, NFT tutorial. I think I can go with this. I've not yet NFT tutorial. Let me rename this. So let me create a new folder. And go to it. through your terminal. Once you're in your terminal, once your terminal is inside NFT tutorial, set up a Node.js project and install hardhat using the following. So go into it and open terminal, npm init. Yes, this is how we set up Node.js. Shift Control V, or you can paste. Okay. Okay, then npm install save dev. Install the hardhat. You can right click and paste, or Shift Control V for my terminal. I'm using Linux. Then we wait. So for this tutorial, we shall be waiting until files load. We are going to have 2 projects, hopefully, or we can have 1 depending on the time. So as the file is loading, after the install has finished, run the following to pop up an interactive CLI that will help you set up your new hardhat project. So that means that after this installation, you're going to run npx hardhat. Okay. I'm going to select create a JavaScript project and say yes to the other questions at the end. Hardhat will install any other dependencies it needs and set up a boilerplate project for you. So since this is taking time, we can go through so that once we start, we are faster. Installing Open Zeppelin contract. You learned about Open Zeppelin contracts in the ERC20, where we built our own cryptocurrency. Open Zeppelin also provides templates for NFT contracts, and we will use those as starting point. Unlike Remix, we cannot just import the contract from a GitHub URL this time, but Open Zeppelin publishes their contracts as a npm package for this very reason. So we will install that to get access to ERC 721 NFT contracts in your terminal. Run the following. So today we have many commands. Hopefully my internet is faster. Looks fast. Okay, that is done. That is successful. So now we are running npx hardhat. Create JavaScript project. Yes. What do you want to do? Project root. Okay. To add a git ignore. Yes. And yeah, I think we have finished that. Install the Open Zeppelin npm install save dev. Okay, writing the NFT contract with OpenZeppelin contracts. With OpenZeppelin contracts now installed, we can move on to writing our Solidity code. So create a new Solidity file. We'll name this nft.sol. Okay, what I'm going to do is now to start my develop environment with code. So I'm going to start my Visual Studio Code. Write the following code in that file. Okay, inside the contract. So Visual Studio Code has started. So inside contracts, yes, we have lock.so. So we are going to create a new file called nft.sol. Okay, I think my ID had not yet started well. So nft.so, inside the contract folder of your hardhat project, write the following code in that file. So this is the code, and we are going to go through it quick as we. Okay, so this license must be there, licensed MIT, then the Solidity version 0.18. Put OpenZeppelin contracts. This will help us in showing that we are using an NFT contract. NFT's ERC20 signifies that the contract we are creating imports ERC721. Contract NFT is ERC721. Constructor, so the name and the symbol. Okay, mint message.sender. So this means that the minter is the person who's going to deploy a smart contract. Okay, the code is fairly straightforward. We import the ERC721 contract from OpenZeppelin and then initialize it during the constructor. We also use the internal mint function to mint an NFT to ourselves. To make sure you got the code right, open up your terminal again and type npx hardhat compile. So terminal, or you can say run. I think there is also terminal here. There is no terminal, so I'm going to terminal, new terminal, and paste. Right click, paste. So npx hardhat compile. Sorry, so I have to change the version. nvm use v18.18. Once I have two versions, I want of Node.js, I want to use the latest version. It's a node version. This is version 18. Then in this contract folder, I'm going to delete and recompile. Nothing to compile. Okay, since I've compiled all of them, let me leave it at that. I needed to delete initially, but that's okay. So if there are no errors and your contract compiles just fine, you are good to go. Writing the deploy script. Let's deploy this contract to the Sepolia test network. To do so, we need to write a deployment script for hardhat and then configure it to deploy to the correct network from the correct wallet. By default, hardhat provides a sample deploy.js script under the secrets folder where we'll replace all the code in that file with the following. Okay, so we have scripts here, and let me increase it, but I think the previous was fine. So in deploy.js, we are going to replace we can go through this code. So we start importing HRA. This is requiring hardhat. So this is a JavaScript file that is used to deploy our smart contract. So we have a main function, async function main. Since async is used when you're going to use await like we use here. So we start by declaring NFT contract await. We're waiting deploy the NFT contract. NFT is a contract name. It's this one, contract NFT. Okay, await NFT contract, wait for deployment, then console.log. So we want to log the address on which the contract has been deployed to, and call the main function to catch if there is any error. Okay, that's straightforward. So we are not going to be clearing a lot because we shall need configure the network. We have a deployment script ready, but hardhat currently has no idea which network to deploy the contract to, or what wallet to use for doing so. To do that, we need to do some configuration for hardhat. First, create .env file inside your hardhat project folder and add the following. So inside the hardhat project, your file .env. So we have a QuickNode RPC URL. In my case, I'm going to use Infura. You can use QuickNode, Infura, or Alchemy to get a test RPC URL. And then private key. Are you wondering what is an env file? File that contains environmental variables that are used to configure an application's environment. Environmental variables are variables that are set in the operating system's environment and are used to configure an application's behavior. Environmental variables are used to store configuration information that an application needs to run. For example, an application might need to know the location of a database or the API key for a third-party service. By storing this information in environmental variables, the application can be configured without having to modify the application code. So this is it. .env You can read through. Head over to QuickNode and sign up. So for me, as I said, I'm going to use Infura. So when you come to infura.io, I need to sign out. So when you come to infura.io, there is a login button around in the right corner. So you can click on login if you already have an account. If you don't have an account, you sign up. Email, password. Verify you are human. Password is incorrect. So when you come to here, do it later, or you can choose, then you can create sort of create a new API key, or you can use, for me, since I created API keys, I'm going to use those ones. So you come here to active endpoints, not all endpoints, active endpoints. We are going to be using Sepolia testnet. So you have Ethereum Goily mainnet, Ethereum Sepolia. So I choose this endpoint, and then the private key. So today I'm going to use a new wallet. That's why I'm going to use this. Hopefully this MetaMask works well. Okay. So this is this MetaMask seems to has some funds. So account 2, I'm on mobile testnet. So let me change to Sepolia. Account details, show private key. So with Remix, you don't need this since it sends an injected provider. Copy, done, and Okay, we are finished. Important, if you haven't already created a separate account for development, so that account is for development. I don't have any real funds on it. Does not have funds on Ethereum mainnet. Do so now. Many people have made a mistake with this and accidentally ended up revealing their private key, which has led to loss of funds. Make sure the private key you use here only has testnet and no real money. And when to get your private key, you can export it from MetaMask. To do so, open MetaMask, click on account details for an account you want to export, and click on export private key. Copy paste the value and put it in your .env file as the value private key, which you have done. At this point, double check you have named your .env file properly and it is properly located in the NFT tutorial folder, not a subdirectory. Okay, or anything else. Also make sure that in the .gitignore file that hardhat automatically set up for you, .env is listed there. So we have .gitignore. So .env is here, .env. Okay. Open up your terminal and type npm install.env. So install.env. Okay. Now open up the hardhat.config.js file and let's configure the Sepolia network and the wallet. Replace the code in the file with the following. So hardhat.config.js. So this is our configuration code. Require .env, so require .env.config. Module export solidity. Networks, define the Sepolia network parameters here. So process.env.quicknode URL. Then accounts, this is how you define your private key. Okay, hopefully we have everything. We are now all set and done and ready for deployment. Deploy your contract. To deploy your contract, open up your terminal and run the following command: px run script deploy.js. Network is Sepolia. So this deploy.js must be the same with this file. If you have another file here, you change this file name, deploy.js. So, and since in our deploy we have this console log, hopefully we are going to have our address. So network Sepolia doesn't exist. And scripts / deploy.js network Sepolia. see why I'm getting this error. Okay, so one of the reason I could be getting this error is because Control S I did not save. This is Control S saved, Control S also saved. Make sure that I've saved everything else. Saved. I think x hardhat compile. And now let me try to run script. Cannot be compiled series on the associated version. Pragma statement, this file does not match with the configured compilers. Okay. In your config, change the pragma or configure additional compiler versions in your hardhat config. Okay, so we look in hardhat config.js. So solidity NFT contract. So we can come here and first compile. This is very good to debug. So npx hardhat compile and see. These files. These files and its dependencies cannot be compiled with your config. This can happen because they have incompatible Solidity programs or don't match. So it seems Solidity compilers don't match. Make this 17. Verbose. So open zipline is so it needs solidity higher than 0.8.20. Okay, so that means that also save here. Okay. So it has been due to compiler incompatibility, where OpenZeppelin files have a higher Solidity version compared to the files that we are running. So now we are downloading compiler version, and then we shall so compile 12 solid files successful. That means it has compiled all the ERC 721 Zeppelin files also. So now we can run deploy. So now we have deployed successfully. So this is a deployed contract. Can copy it to a place, into a text editor, so that in any case if we clear, let me also remove this. Okay, so we are going to put it there. This command will output some logs to your console where it will compile your contract and then deploy the Sepolia test network. It will also give you the contract address of the deployed contract. With a contract, it gives you and look it up on Sepolia. So we are going to look this up on Sepolia testnet. So this is the process that you go through to deploy on your local machine, but helps you in debugging and in many things. So our contract NFT ITM has been deployed. So congratulations. Why should you use environmental variables? Because storing these variables in the config file can leak them, because environmental variables automatically encrypt the values and keep them safe. Config file can leak them if you push your code to GitHub, whereas the .env does not get pushed. I think that is it. Okay, so we have successfully completed the first task, and our second is going to be a more detailed NFT. So let's we are going to take on something a bit more complex. So we are going to build an NFT with metadata. So if you come to this platform, you can learn about IPFS, but today we are going to concentrate on building your own NFT collection with metadata. Okay, again, this example we are also going to use local environment where we are going to build with our local build environment such as VS Code. Okay, so as this is loading, so okay, build your own NFT collection with metadata stored on IPFS. So the other one, we've just built a simple NFT. We want to build an NFT collection which has metadata that we've stored on IPFS. So for your NFT, you can add the NFT in your smart contract, probably if you're using things like SVGs, or you can build an NFT where you have a representation in a decentralized database like IPFS, and then you query it from a smart contract. So this is what you are going to do. Now it's time for you to launch your own NFT collection and store its metadata on IPFS. Requirements: there should only exist 10 LLANOB 3 punk NFTs, and each one of them should be unique. So I think we are going to make central code punk NFTs. Users should be able to mint only one with one transaction. The metadata for the NFTs should be stored on IPFS. There should be a website for your NFT collection. The NFT contract should be deployed on mobile testnet. Let's start building. Prerequisite: you should have learned the theory. Build IPFS. First, we need to upload our images and metadata to IPFS. We'll use a service called Pinata, which will help us upload and pin content on IPFS. Once you've signed up, go to the Pinata dashboard and click on upload. I think I have Pinata here. Okay, let me check on this. So you come to pinata.cloud and log in. When you log in, you go to the dashboard. So this is my dashboard. I've uploaded some of these, but go to the dashboard and click on upload, and then on folder, download this folder. So you're going to download this folder to your computer and then upload it to Pinata. Name the folder W3 punks. Okay, I think it is here. I've uploaded it. So for you to upload, go to files, and then come here to upload. Then when you click on upload, ask for a file or a folder. So you upload that folder that you've downloaded, and I've uploaded mine here, and then upload it to Pinata. Name the folder this. So now you should be able to see a CID for your folder. Awesome. So for my folder, this is the CID here. Yes, so you can check that it actually got uploaded to IPFS is by opening this UNFT CID. So when you open this, let me close these, and then my CID so you can see all the 10 images of my NFT are uploaded. Okay, the image for NFTs have now been uploaded to IPFS, but just having images is not enough. Each NFT should also have associated metadata. We will now upload metadata for each NFT to IPFS. Each metadata file will be a JSON file. Example of the metadata of NFT1 has been given below. So most of the time the metadata is in JSON files and has most name, description, image, and other properties or other attributes. Now note how image has IPFS location in it instead of HTTP URL. Also note that because you uploaded a folder, you will also need to specify which file within the folder has the correct image for the given NFT. Thus, in our case, the correct way to specify the location for an NFT image would be this. Okay, so we have a pre-generated file for the metadata. You can download them to your computer from here. Okay, upload these files to Pinasa and name the folder metadata. So I've uploaded and my folder is called metadata. So to upload, you come up here, upload. Okay, now each NFT's metadata has been uploaded to IPFS, and Pinata should have generated the CID for your metadata folder. You can check that if actually got uploaded. Okay, contract. For the contract, we will use simple NFT contract. We will also be using ownable.sol from OpenZeppelin, which helps you manage ownership of a contract. By default, the owner of an ownable contract is the account that deployed it, which is usually exactly what you want. Ownable.sol lets you transfer ownership from the owner account to a new one and renounce ownership for the owner to relinquish this administrative privilege, a common pattern after an initial stage with centralized administration is over. We would also be using an extension, this. Okay, so to build the smart contract, we would be using hardhat and Ethereum. So Ethereum development environment and framework designed to full stack development in Solidity. In simple words, you can write your smart contract, deploy them, run tests, and debug your code. To set up a hardhat project, open up a terminal and execute these commands. So we are going to cd. We are going to Ethereum DeepDive. Yes, I think now we can. In this place, we can make deal and copy and paste. So make this directory, change to that directory, and inside that directory make a new directory, hardhat. And we change to hardhat. Then we initialize npm So we are going to install hardhat package. And then npx hardhat. Make sure you select create a JavaScript project and then follow instructions in your terminal. If you are a Windows user, you will have to add more dependence given below. Okay, and this one is done. Npx hardhat. Okay, great. Yes. Yes. Okay. Now let's create a new file inside the NFT IPFS hardhat contracts. Okay, let's wait for it. Now we can close this first project. Okay, so this is successful. So in the same terminal now install OpenZTrain contract as we would be importing a 721 contract in our punks. Okay. Now let's create a new file inside the NFT IPFS hardhat contracts. So let me start my developer environment. Add contracts. I'm going to delete this contract, and then inside contract lw3punks.solve. So this is a smart contract. We are going to explain it. It's quite so its version is 0.8.4. Now we don't this ERC 721. I think we shall use a 20, and then we shall have to check and see if it still works. So is ERC 721 enumerable and ownable? So we shall import ownable, whereby you can assign ownership to another. Address using string for base token URI. Base token URI for computing token URI. If set, the resulting URI for token will be the concatenation of the base URI and the token ID. Okay. Price is the price of one NFT, which is 0.01 Ether. Paused is to pause, because pause the contract in case of an emergency. Max number of LW3. Total number of token IDs minted. Modifier only owner, not paused. So require it's not paused. So the contract must not be paused, where we check if the person operating as the owner is the real person who deployed the contract. And ERC 720 constructor takes in a name and a symbol to the token column name. The token collection name in our case is W3punks and symbol. So constructor for base URI is set to base URI 4 for the collection. Okay. So this is the constructor, string memory base URI. So the name and the symbol base URI is being assigned. Base token URI is being assigned to this base URI, which is declared up here as a string. Okay. We have a function to mint public payable, so mint must be payable, and must also the tokens must be minted when the contract is not paused. So these are conditions to ensure that you don't mint beyond the supply of the tokens, because there are 10 of the NFTs, because there are 10. And you check for the price. It has sent, if the price is lower, then you're not allowed to mint. Okay. This overrides the open discipline is ERC20 implementation, which by it returns an empty string. So when you look at this, the contract is well documented, and I'm going to also leave it. You can keep reading. I want to to run it and test it since I've changed the version. Now let's install the .env package to be able to import the env file and use it. Okay, copy. So we are going to copy the environment variables that we have used in our initial NFT. Create a .env file in the hardhat folder and add the following lines. Okay, we have go to QuickNode and sign up for an account. I use Infura. If you already have an account, login provider that let you connect to various different blockchains, we will be using it to deploy our contract through hardhat. After creating an account, create an endpoint on QuickNode, select Polygon, and then select mobile network. So here we are going to create a new file called .env, and in here I click continue in the bottom right, and I click and add the .env. Okay, but if you previously set up a mobile endpoint, you can keep using that one. If you have any other endpoint from the past, to delete it and create a new one. To get your private key, you need, okay, now we can copy this, so paste it in this .env. So for this we are going to deploy on Mumbai. If I go back to my Infura endpoint and I go to Polygon Mumbai, so I copy this, also here the private key, I can go back to my previous tutorial, .env, so we don't have a .env. Okay, let me get my private key. And let me also change this to Mumbai. Okay, we paste, and we go back to, let's deploy the contract to mobile network, create a new file or replace the existing default, deploy the JSON and the scripts folder. Remember to replace your metadata CID with the CID you saved to your notepad. Okay, so in scripts I can say new deploy. This time I'm going to to use new deploy.js. Hopefully my contract is okay. So in new deploy.js, so metadata, this is a CID for my metadata. I copy it and so now deploy we required the hardhat also .env to be configured, and then in the main function we declare the metadata URL. Then this will await the contract name while passing the metadata. Okay, so see that the contract is linear at LW3 punks, and we shall pass in the metadata so that we can sync the NFT with the metadata. I named this new deploy.js. Alright, so the main is to check for errors, and so in the hardhat.config.js file and the Mumbai network so that we can deploy our contract to Mumbai. So the lines in the hardhat. Okay, so here is where we add in the networks and add the Mumbai Solidity version. Okay, so we are going to change some things. One is this version, because OpenZeppelin uses v20, so you are going to change that. And let's compile. Let's see if we go. So you open terminal pointing at hardhat directory and execute the command. Must open to hardhat, point to hardhat, then npx compile. Let me clear. Okay. Npx hardhat compile. So here there are one or more errors. Invalid value undefined hardhat.network Mumbai URL expected value. String. If I change the version. So let's compile again, see what the issue is. Okay, I think I need to put my load env here, and that is it. npx hardhat compile. So line 65. So I think this has an issue. I think for Open Zeppelin, we need to reduce the version. So I think reducing the version of Open Zeppelin to 4.9.0 removes the error. Now let's compile. So we have compiled successfully. Okay. So you need to be upgrading as your knowledge as versions of upgrade. So we have been here in npx hardhat run scripts. Network is Mumbai. So we are going to use new deploy.js. So this is our deployment address. Copy it here. And then quickly set up our website. So my app, folder my app, we have hardhat. So create this my app in the terminal, point nft folder and type npx create at. Let me first delete this, and let's create our frontend application. Okay, what's wrong with my network? I think I should be ready to go. try it one more time. Hopefully this time everything goes well. Okay, so that has been installed well. Now we have to change to my app. So cd npm and dev. So our application is launching well. And now first so then we look in that directory, we install the W3D model. And then in the same terminal also install Ethers.js. We install v5 specifically since the new v6 is breaking. Okay. Installing dependencies. Your public folder. In your public folder, download this folder and all the images in it. Make sure that the name of the downloaded folder is this. And replace all the contents of home. Okay. I'm going to download those. Let's first continue. Sure that the name of the downloaded folder is this. Now go to styles, press all the content, home module.css. Okay. So now we have global.css. I think the folder structure varies. Since this is Nextjs 14. So these are next two folders. I need to be so these are last two folders need to be structured within a Nextjs 14 folder structure, and then we run the code. Good enough, we have deployed the smart contracts. Let me stop here on this tutorial, but hope the idea has been obtained. Okay, thank you so much. See you in the last section, in the last tutorial. Bye bye.